This video presentation is brought to you by the Pro Mathematics Academy.
Welcome to another video presentation brought to you by the Pro Mathematics Academy. In this video, we'll be looking at trigonometric proofs and solving trigonometric equations. Now, this particular example is taken from the CAPE Math 2018 exam, Module 2, question number 3, which asked us to show that sine 2 theta minus cos 2 theta plus 1, all divided by cos 2 theta plus sine 2 theta minus 1 is equal to sec 2 theta plus tan 2 theta. 8 marks. And part 2 says, hence or otherwise, determine the general solution of sine theta minus cos theta plus 1, all divided by cos theta plus sine theta minus 1 equals 0. So without further ado, we jump right into our solution, right? And when proving the equivalence between trigonometric expressions, we want to start with our left-hand side and simplify it until we get the right-hand side expression, or we can start with our right-hand side expression and work it all the way to our left-hand side expression. So for this particular example, I start with my left-hand side, which reads sine 2 theta minus cos 2 theta plus 1, all divided by cos 2 theta plus sine 2 theta minus 1 is equal to sine 2 theta minus cos 2 theta minus 1 in bracket, all divided by sine 2 theta plus cos 2 theta minus 1 in bracket. So what I did there was I switched my sine 2 theta with my cos 2 theta from the denominator and factored out the negative from the cos 2 theta plus 1 in the numerator. This then gives us our left-hand side being equal to sine 2 theta minus cos 2 theta minus 1, all divided by sine 2 theta plus cos 2 theta minus 1 times sine 2 theta minus cos 2 theta minus 1, all divided by sine 2 theta minus cos 2 theta minus 1. And this is multiplying our expression by the conjugate of the denominator, right? Which then means our left-hand side is equal to sine 2 theta minus cos 2 theta minus 1 all squared, all divided by sine squared 2 theta minus cos 2 theta minus 1 squared. And if you look at our denominator, we will recognize that this is the difference of two squares. That is a minus b times a plus b is equal to a squared minus b squared. Also recall that a plus b all squared is equal to a squared plus 2ab plus b squared. And a minus b all squared is equal to a squared minus 2ab plus b squared. We'll be applying this to our expressions both in the numerator and in the denominator. This then gives us sine 2 theta minus cos 2 theta minus 1 all squared divided by sine squared 2 theta minus cos 2 theta minus 1 squared, right? Copying this expression from above, equals sine squared 2 theta minus 2 sine 2 theta cos 2 theta minus 1 plus cos 2 theta minus 1 squared, all divided by sine squared 2 theta minus, in bracket, cos squared 2 theta minus 2 cos 2 theta plus 1 squared. This then gives us sine squared 2 theta minus 2 sine 2 theta times cos 2 theta minus 1 plus cos squared 2 theta minus 2 cos 2 theta plus 1 in our numerator, all divided by sine squared 2 theta minus cos squared 2 theta plus 2 cos 2 theta minus 1, which is equivalent to sine squared 2 theta plus cos squared 2 theta plus 1 minus 2 sine 2 theta cos 2 theta minus 1 minus 2 cos 2 theta in our numerator, all divided by sine squared 2 theta minus cos squared 2 theta plus 2 cos 2 theta minus, and this is where we take our 1 from our denominator previously, and we rewrite that 1 as sine squared 2 theta plus cos squared 2 theta, which then allows both our numerator and denominator to simplify out to 2 minus 2 sine 2 theta cos 2 theta minus 1 minus 2 cos 2 theta, all divided by minus 2 cos squared 2 theta plus 2 cos 2 theta. And we have to remember here that sine squared theta plus cos squared theta is equal to 1. That is our fundamental identity of trigonometry, and we applied that in our numerator and denominator. So now we have minus 2 cos 2 theta plus 2 minus 2 sine 2 theta times cos 2 theta minus 1, all divided by minus 2 cos 2 theta times cos 2 theta minus 1. So that is factoring out 2 cos 2 theta from our denominator. Now we look in our numerator for the same cos 2 theta minus 1. So this then allows us to factor out negative 2, which gives us minus 2 times cos 2 theta minus 1 minus 2 sine 2 theta cos 2 theta minus 1, all divided by minus 2 cos 2 theta times cos 2 theta minus 1. Here we recognize that we have cos 2 theta minus 1 being a factor of both the numerator and denominator. So we now have minus 2 times cos 2 theta minus 1 divided by minus 2 cos 2 theta times cos 2 theta minus 1 minus 2 sine 2 theta times cos 2 theta minus 1, all divided by minus 2 cos 2 theta times cos 2 theta minus 1. And then we can cancel, where we recognize that cos 2 theta minus 1 divided by cos 2 theta minus 1. That becomes 1. So we cancel out those terms, and now we're left with 1 divided by cos 2 theta plus sine 2 theta divided by cos 2 theta, which is equal to sec 2 theta plus tan 2 theta, QED. So that is the end of our proof. And as I said, guys, the difficulty of this proof is 9 out of 10. So moving right along to finding the general solution. We now move on to part 2 of this question, which asks us to find the general solution to sine 2 theta minus cos 2 theta plus 1, all divided by cos 2 theta plus sine 2 theta minus 1 equals 0. We have to simplify this expression, which would allow us to substitute our right-hand expression for this expression, which gives us sec 2 theta plus tan 2 theta equals 0. We then rewrite our sec 2 theta as 1 over cos 2 theta plus sine 2 theta over cos 2 theta for our tan 2 theta equals 0. And then we are allowed to add our numerators, which gives us 1 plus sine 2 theta all divided by cos 2 theta equals 0, which means that our numerator 1 plus sine 2 theta is equal to 0. Thus, we are really solving for sine 2 theta equals to negative 1. So how will I know when this happens? I go ahead and I draw my sine graph. Now, drawing my sine graph allows me to look at my sine graph to see where this graph will be equal to negative 1. I identify those 4 points as the 4 points where the sine 2 theta graph will be equal, the sine theta graph will be equal to negative 1, and I try to write down a pattern for that sequence. So I recognize that at negative pi over 2, we will have a solution. Also at negative pi over 2 minus 2 pi is a solution, and negative pi over 2 plus 2 pi is also a solution, and thus I can write down my general solution as negative pi over 2 plus or minus 2n pi. Right? So for sine 2 theta equals negative 1, we have 2 theta equals negative pi over 2 plus or minus 2n pi. So this would mean that theta is equal to pi over 4 plus or minus n pi. And that is the general solution. So the general solution usually has a sequence as the solution, and that is our final answer. Thanks for watching this video, guys.
That is it for this video. Please remember to hit the notification bell, like, share, and subscribe for future post notification.